We have done quite a few sessions on examples of motion on rough surfaces, so it's time to see if we can apply our knowledge to solve some problems on motion on rough surfaces, numerical problems or otherwise. So here comes the first question on this topic, and as expected the problem will be an easy one because this is the first problem we shall be doing on friction given by a rough surface. The question says, a block of mass 1.2 kg starts along a straight horizontal track with an initial velocity of 6 meters per second and comes to rest after 4 seconds due to friction. Find the force of friction on the block and coefficient of kinetic friction between the block and the track. You have seen so far, as I have solved problems, I have usually insisted on drawing a figure. It is often said that a problem correctly visualized with a diagram is half the problem solved. I'll also suggest that if you have got slightest doubt about the language of a problem, it's better to visualize that with a diagram. As it becomes clearer, you can attempt with a lot of confidence. But at the same time, I will not insist that all the time you have to draw a diagram. It depends on your level of confidence and matter of choice. Usually you should go for a figure, but in some cases if you are very confident, you can even avoid drawing a diagram and straight go head on into the problem. So here I suggest to draw a diagram here. As the question goes, as you can see, this is the block of mass 1.2 kg resting on a rough horizontal floor. So the question says the mass of the block m is equal to 1.2 kg. And initially velocity of this block to the right, say in my figure, that is given to be 6 meters per second. So here we show the initial velocity of the block, and that symbol for that is u. U is given to be 6.0 meters per second. I can see the data is given up to 2 significant figures. I'll keep that in mind while reporting my answers. At the very beginning, suppose time was 0, and a later time after 4 seconds, suppose the block has come somewhere here along the horizontal track and it has come to rest at this point, right? So this is the time according to the question. This time is 4.0 seconds. It has come to rest. It means its final velocity v is 0. So the question says find the frictional force acting on the block. See, as the block is given the motion with u as 6 meters per second, they have not mentioned about any propulsive force. It only means the only force that's acting in the rightward direction, let us take to be our positive direction here to the right, and the only force acting on the block during its motion is nothing but the frictional force given by the rough floor. They did not mention any propulsive force here, so you can easily guess as the block moves under this frictional force, this force will be kinetic friction because the block is indeed in motion. So it's kinetic friction. And the frictional force being to the left, resisting the motion to the right, is an acceleration negative. That's retardation onto the block, because of which the velocity comes down from 6 meters per second up to 0 after a time t. So let us apply the corresponding equation of kinematics. You'll recall we must apply here the equation v is equal to u plus at for the motion of the block. And here they say the velocity final of the block is 0. So this is 0 here. Initial velocity to the right, that's positive, it is 6 meters per second. Acceleration I don't know, and the time they have said is simply 4.0 seconds. From here we solve and find acceleration value is coming out to be minus 1.5 meters per second square. The negative sign is expected because I have taken direction to the right, direction of motion to be positive, and acceleration negative value means the acceleration actually is retardation. The block retards, decelerates under this frictional force directed to the left. And once you have found this acceleration of the block to be negative, we can find out by applying second law of Newton that says that applied force is equal to mass into acceleration. Hence, the frictional force acting on the block is coming out to be its mass. Mass was given to be 1.2 kg in the problem. and acceleration just now found, keep the minus sign, don't play with that, minus 1.5 meter per second square. When you multiply, it's coming out to be minus 1.8 Newton. This is the kinetic frictional force acting on the block during its motion. Its magnitude is 1.8 Newton and minus sign signifying, as expected, that the frictional force acts to the left in my figure, which resists its motion to the right. That's why this minus sign, meaning the direction of the frictional force to the left. The first part of the problem is over. Let's go to second part of the question. They said find coefficient of kinetic friction between the block and the track, and for that we need to recall the law of kinetic friction. If you can understand here that although the motion of the block to the right involves only the frictional force acting to the left that retards this block, there are two more forces acting on the block in the vertical direction. These two forces, of course, are the force of gravity acting on the block downwards exerted by the earth, and the normal force acting vertically upwards given by the track on which the block is moving. So, if this is the force of gravity mg and this is the normal force n upward, a quick look at the figure is enough to tell us that since the block doesn't have any vertical motion, it only means that numerically the normal force acting on the block must be equal to the gravity force because there is no vertical motion. And then again from here I can write down that this n is equal to mg, and recalling the law of kinetic friction, we know kinetic frictional force Fk is given by mu k, that is coefficient of kinetic friction multiplied by the normal force. That's in my case coming out to be mu k into mg, and from here it follows that the kinetic frictional coefficient mu k is coming out to be Fk, kinetic frictional force, divided by mg. We put the values here. Fk has been found to be numerically, that is, we take magnitude part only, that's 1.8 Newton. The mass of the block was 1.2 kg, and the value of g is, of course, we take, unless otherwise stated, 9.8 meter per second square. You solve this, calculate it, and show that the value of mu k is coming out to be 0.15. I write this value here, and this is the kinetic frictional coefficient between the block and the track. This is the second result of this question. I have highlighted my results here. Remember, I expressed both my results up to two significant figures in accordance with the data of the question. And once again, let me tell you, remind you, the minus sign here signifies the frictional force resists the motion, acts to the left, which is opposite to the direction chosen positive by us.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.